a 0 to start doing your factoring. Well, this is now, what do you do when you don't know a 0 to start? Okay. This is for what we do to figure out where are your possible rational zeros. What are rational numbers again?
Numbers that aren't crazy decimals.
Well, those can still be crazy decimals, but how about numbers that just aren't imaginary? All right. So what happens here is, obviously with the polynomials, you've noticed that when you factor something, you could get imaginary solutions. You can get imaginary zeros and whatnot. So what happens is, when we use this stuff called rational, we're trying to find some rational zeros, it's going to allow us to figure out where do you start factoring when you don't know where to start. Okay, if that makes any sense. It's giving you the possible starting points. Okay. Also, this is the reason why we did so much stuff with that synthetic division, because when we use these rational zeros, we use synthetic over and over and over again because we are going to be fishing for zeros. We're just searching for them. Okay. For example, what happens here is we're going to get a function like this. F of x is x cubed plus 2x squared minus 11x minus 12. And obviously it's a 4-term function. Whenever you see 4 terms, generally speaking, you guys would sit there, okay, can I group them? And in this case, if you grouped it, it's not getting you anywhere, is it? No. So the other day, you were given a 0 to start with, and then you were able to use synthetic because you wound up with a 0, and then you had a factorable, maybe a factorable trinomial. If not factorable, you could have used quadratic formula and get the other possible zeros. So what happens here is, where do you start? What are your possible factors? What are your possible zeros? Well, there's this thing called the rational root theorem, because why wouldn't there be? And it is very, very, very long-winded and gross, so don't write it down. Basically, it is your possible zeros are going to lie at the factors of your tails. What are your factors of 12? 1, 2, 3, 4, 6, 12. So it's going to be plus or minus 1, 2, 3, 4, 6, and 12. Divided by, what's the leading term coefficient? 1. So that'd be just plus or minus 1. So technically, this function has 2, 4, 6, 8, 10, 12 possible rational zeros. Okay? And what we do is, we just pick one to start looking to see if it works.
You can only have 3 zeros, right?
Correct. This is only a half 3 zeros, but what happens is that you don't know where to start. So this gives you the ability to figure out where to start.
Yeah, but like then once you find 3 of your zeros, you're not stopping.
Yes, sir. Yep. That's exactly right. So what's happening here is we list out the possible zeros. What's up? Okay. You're looking at, to get the possible zeros, bless you, possible zeros are always whatever the factors of the last constant is divided by the leading term's coefficient. So if that was a 2, this would be a plus minus 1, plus minus 2. That's all it meant. Okay. Yeah. Yep. And if you think about it, on the other day when we had zeros that were fractions, those fractional zeros came from like 3x plus 1. It was negative 1/3, things like that. Those were possible zeros. And that's where this kind of stuff comes from. Okay. So the idea is, those are your pop. What's that? Yeah. And as I didn't want to jump right into stuff with fractional amounts, because usually you'll find your zeros first before you get to the fractions, and then as we synthetically go through it, it becomes easier and easier and easier. This becomes so efficient of a way to do all of this. Yes, ma'am.
So that end is always on top?
Yep. The coefficient, the constant is always the numerator. The leading term coefficient is always the denominator. Yes, sir. Because you could get fractional zeros. Remember how we had, like I just said, if you had a term of 3x minus 1, your 0 was 1/3? That's why that works. Okay. So, for example, we go back, I think I have this one here again. if I wanted to continue this one, let me show you what this is going to look like as we go further. So we set our possible zeros. We're at plus or minus 1, 2, 3, 4, 6, 12. And they were all over, in this case, they were all over 1. Plus or minus, all right? Now, where do you start when you want to try to factor it? Yeah, I always start at 1. Okay? I always start at 1. So what we do is we use our synthetic division. And we know our coefficients are 1, 2, negative 11, negative 12. And I just put 1 up front. And I try and see if it works. And as you go through these, you start to realize you probably don't have to completely finish synthetically dividing because you'll notice that it's not going to be a 0. Okay? This is one section, as we go on to this, you're probably going to use an eraser along, right? Because you go through a few of them. So, first rule of synthetics, to drop this, you have 1, multiply, add, and as you see right now, it's not going to work. Positive 1 won't work, will it? It won't give me a 0. No. So I try again, I just erase, and I try with negative 1. Okay? And I just redo it. Okay? But how hard is synthetic?
Super hard.
But here's the thing, you shouldn't have to go that far. Usually you're going to find a 0 within the first, second, or by second or third try. It's very rare that you have to go to the 4th or 5th term. Okay? So I use negative 1. Oops, did I screw that up? Yeah, that's why. I was going to say, I thought this was going to work. And look at that. I found a 0. Remember, when you find a 0, what should you do to this?
Circle it.
Circle it. So I know that negative 1 is a 0, which means if negative 1 is my 0, what's my term? X plus 1, thank you. So down here I'm going to write x plus 1. Now what happened to this function here? It turns into a quadratic, good. It drops a degree and you get x squared, plus 1, x minus 12. What times what's negative 12 you add together to get positive 1? Very good. So your terms of factoring then, x plus 1, x plus 4, x minus 3, and what are your zeros? Negative 1, negative 4, and 3.
Oh. Once you find a lot.
Now,
Oh, yeah.
yeah. Now, yes, sir.
Will it always be plus or minus?
Yes. Yep. It'll always be plus or minus. Now, the idea here goes, as you start going through this, you're going to be able to find zeros. You're going to be able to bring down degrees. As we start with higher degree stuff, if we start with a 5th degree polynomial, then our next one will be 4th degree. You can continually do this over and over and over again. Yes, sir. Yes. Yep, those are your options. Those are your possibles. All right, and then I always start with 1, and I work my way through it. Okay. All right. All right. Take a look at number 3 up here. I know that it looks kind of gross because you have a 56, but we have x cubed plus 14x squared plus 41x minus 56. So we have to know our factors of 56.
1.
Thank you. 1. Very good.
Actually, plus or minus 1.
So if I look at the first one, it's plus or minus 1, 2. Do we know if we have 3 works? No, you don't get calculators.
Wow. Yeah. That's important.
Yeah, I'm serious. You don't get calculators for this. We haven't had to use them at all yet.
Yes.
3 does not work. Does 4 work?
Yes.
5 does not. Does 6?
Yes. Yeah. Oh, wait, never mind. I mean 7.
And then obviously you get to 8, then you're working your way back down. So 14 would be what? 4 and 14. 14, I believe. And then 28 and 56. And it's just all over plus minus 1. Okay. Now, if you started to look for your zeros, to start factoring that then, because I know a lot of the instructions say list the zeros. Well, you might as well do the work then. So I'm usually just going to say, hey, list your zeros and solve for all your zeros. This section talks about finding real, but I'm just keep saying find all. The next section says find all, so we're going to keep finding all. So it's just the same thing. All right. We probably won't get to that one little bit of 6, 7 today. So let's see, what was our term? We had 1, 14, 41, and then negative 56. Where do you start? 1. Huh. That was a good place to start, wasn't it?
Wow.
Sometimes. All right, so we got a 0 right off the bat. So if I have a 0 at 1, I circle it. What's my term that made the 1 a 0? X minus 1. So I have x minus 1. Now here I have x squared plus 15x plus 56. Now, you can continue to use synthetic, but once you get to a quadratic, what times plus 56 you add together to 15? There you go. Once you get to a quadratic, just try to factor it. Zeros, 1, negative 7, negative 8. What are your tails doing?
Why is it negative? Oh, my bad.
Your tails are down up. Third degree. Yeah, I mean, you're thinking about just a quadratic. Remember, it's the third degree one. So you're down up. First term was positive. Okay. All right. That's what we're looking at. Okay. What happens when you have larger degree, or let's look at number 7 here. Before, so now we have a leading term coefficient, so I want to show you what it's going to look like with this. We have 5x to the 4th, 12x cubed, minus 16x squared, plus 10. As you're writing that, bless you, as you're writing that down, what are you missing? An x. So it might not be a bad idea as you're writing it out, put a 0x in there, because you know with 4th degree, it should have 5 terms. All right. So this one only has the 4, so you got to put a placeholder in, because we know we're going to have to use it anyway. So might as well get out ahead of it. Anytime that you notice that as you're writing stuff out, do it. It just makes sense to do it then. Okay. So we have our plus minus of our constant. Well, what are your factors of 10? 1, 2, 5, and 10. And your factors of 5? 1 and 5. Now, technically, this just means that we could have possible zeros of 1/5, 2/5, because here, what's 5 over 5? What's 10 over 5? So they start to duplicate themselves through. Right? It's just showing that you do have the possibility of a fractional 0. All right? Start with your synthetic again. As you do your synthetic, let's go over a little bit. Thank you. It's not the end of the world if you don't do plus minus, because it's going to wind up being plus minus no matter what. If I start my synthetic here, we have 5, 12, negative 16, 0, and 10. And I like to always start at 1. You have to start at 1. You start at 10 if you wanted to. Sure. But might as well start at the beginning and work your way down. That way you don't skip something. And then you just go in order. Go 1, negative 1, 2, negative 2, 5, negative 5, and so on and so on. That's the easiest way to do this stuff. So bring the 5, multiply, add, multiply, add, multiply, add, multiply, and it doesn't get you there. Okay. So, to the eraser. And I have negative 1. Again, I drop the 5, multiply, add, multiply, add, multiply, add, And that's not going to work either. As you get going into it, you'll start to recognize, oh, that's not going to get me to a 0. Okay. So you erase. It's really nice when you have a smart board for this.
Yeah, when we can try erase. Yeah. What about, no, aren't the desks like
What
that,
is
right?
it?
Why don't we just
Smart
get
boards?
one?
Errors. Gonna make a mess.
Yes.
So I start at 2. Drop and go. What was that, 28? Is that right? And then I'm going to go ahead and say that 2's not going to work. So this is how many have we had to try so far? We've tried 3 of them. So this is our 4th attempt. Wah, 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 wah.
Oh my gosh.
Not really. This doesn't happen at all.
Dude, 5, 6, 3, 5.
Okay.
It's actually going to be negative.
Oh, jeez. I'm not using a calculator. We go ahead and say it's probably not going to work.
Negative 5.
So we have what, negative 17. No, it's negative 7, isn't it? Wait. Negative 13. Hi, good morning. 65.
It's not going to work.
It's not going to work. All right, so should we? I don't know if I want to go with 10, but you want to try? Did you know that you could do this with fractions?
Whoa! No.
Yeah, 1/5.
What's 1/5 times 5?
1.
Okay, that's 13. Well, that sucks. All right. Did I pick one that has no real roots? I probably did.
Can we bump that?
No, photomath's not going to get you anywhere with this. You know what? So here's the thing I just realized because I was putting. I bet you this was a problem that was just list them all. Don't shake your head and just stay with me, Feeny.
Yeah, probably was. That doesn't actually happen.
Probably has no real roots. Anyway.
That's fine.
Let's do.
Oh my gosh, I used all that eraser for a problem that didn't have an answer.
All right, let's try this one. Now here's the thing. That was probably. If I ever asked you to find all the zeros, you're going to be able to find a 0 via synthetic to start with. It just so happened that I picked one that didn't have a real solution to start with. So there's that.
Okay.
Yes.
Well,
So in this one here, again, you have a 6th degree polynomial, which means how many terms should you have as you're writing it out?
7.
You have 7, so we have to have a couple placeholders here. So our tails aren't bad. This is just plus minus 1, 2, 3, 4, 6, 12. All right, factors of 12. As I go to do my synthetic then, 1, 0, -2, 0, -11, 0, 12. And again, where do you want to start? 1. Okay. Start at 1, multiply, add, 1, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. Hey, look at that. Okay. So we found a 0 at 1. Okay. Now, our original problem started at what degree? At 6, which means what degree are we at now? We're at 5th degree, which means, can I factor that like a trinomial though? No, which means I need to do this again. Okay? So we have a 0 at 1, so whenever you start getting these larger degree ones, once you circle your 0, remember, put a term down, that way you remember that you have one of them there. Most of you guys are doing really good about remembering to do that, but just remember, as soon as you get a 0, circle it. Is it possible that this could have multiplicity? Is it possible for any of these to have multiplicity?
Yeah.
So how do you check to see if it has multiplicity?
It has the same.
Test the same number. You test the same number to see if, in fact, it has multiplicity. So I test it one more time at 1.
So you test the thing you just got?
Yeah, because if I get a 0 again, that means it had multiplicity at negative, or it had multiplicity at that 0.
Do you know the multiplicity?
Nope, you don't know yet.
Do we include that 0?
No, good question. Yeah, what happens here is that this, once you get to this 0 here, you don't have to worry about it as you're doing your synthetic, because if you get a 0 here anyway, as you bring across, it wouldn't be there. So if I try it this way, we got 1, 1, 2, 2, 1, 1, 0, 0, negative 12, negative 12, and it didn't have multiplicity, if I did that correctly. You double check because it went fast. Yep, okay. This one did not have multiplicity at 1, so what should I check next? Negative 1. Okay, so I go to negative 1 and I do the same thing. Okay. Multiply, add, multiply, add, multiply, add, multiply, add, multiply, add, and I had a 0. Yes. Yep. Absolutely. Right. You keep reusing the same that you started with. You always use the same set that you wrote down at the beginning, because if they were factors in the top one, they're going to be factors in the second one as you keep going through. So now negative 1 was a 0, which means what's its term? So I bring that over here. I have an x plus 1 now. That was a 5th degree. Now we have a 4th degree. Now, if you look at it, I have a 4th degree, a squared, and a constant. Can't I factor that like I would a regular trinomial? Remember that? Yeah. So I can do that now if I want to try that. So this is x to the 4th minus 1x squared minus 12. What times what's negative 12 you add together to get negative 1? Negative 4 and 3, correct. So I could factor it here, or I can keep doing synthetic. So if I factor it here, I get x squared minus 4 and x squared plus 3. Be okay with that? Yep, the first one's a difference in squares, which means the terms that this creates, well, would be, x minus 2, x plus 2, which means your zeros are at 2 and negative 2. So I'm just listing out all my stuff right now here, and I'll go back and put my zeros in. Oops. And then this last one, x squared plus 3, is that factorable? Yeah. No, because what kind of roots are you going to get?
Crazy.
How about imaginary? You'll get imaginary roots. So my last term would have been x squared plus 3. So here we have 1, 2, 3, 4, 5, 6 possible zeros, which is good because what was the degree? 6. So what are my zeros? I have zeros then at 1, negative 1, 2, negative 2, And then what are the zeros here? Plus or minus I root 3. Very good. And that's what that would do. That's how you would factor that one completely. You're just continually using synthetic division to break it down further and further to something that's manageable. Okay? Those are rational. Okay? And that's the reason. If you can bring out all the rational roots and then be left with an imaginary root or one of those crappy roots from quadratic formula. And that's fine. The rationals just take out all your normal and zeros. Okay? It takes a little bit of time, but as you get used to it, using synthetic division, that's why we learn it. That's why we were looking at it, just searching for zeros. Okay? Because remember, when we first talked about synthetic, we were picking a value of x and finding the value of y at the end. Well, bless you, the values of x we're picking here, we're looking to see if it crosses the x-axis. We're looking to see if that y value is 0. You're just searching for that 0. And we know that zeros generate terms. That's what all this means. Okay, that's where all this comes from. All right. Let's try this one. Okay. Let's try this one. So how many terms do you have? 6. What are your factors at 81? 1 and 81, 3. So plus or minus 1, 3, 9, 27, 81. Okay. Which means if you look at the possibles here, the only fractions you have to worry about are would be plus or minus 1/3. Everything else is just repeated. You see that? All right, so even though it looks like there's a ton of them, 3/3 is 1, 9/3 is 3, and so on and so on and so on. So again, as you start, we have what? 3, 1, 0, 0, negative 243, negative 81. Just by looking at it, do you think 1 or negative 1 is going to work? No. And those are the things you can start to take a guess with. I can tell right away, 3 at 4, there's no way it's going to get me to 243 by doing it that way. So I would say, I don't even think that 3 would get me there. So maybe start at 9. In this case, just take a guess. Or if you want to try it at 3, go for it. We'll try it at 3. It doesn't matter. You know, I don't know if 3 is going to work, but 9, 10, 30, oh, my goodness there. 30, 90, 90, 270, and then I add those together. It didn't get to it, did it? That would be what? 27? Oh, wait, yeah. Oh, hey, look at that. It was 3. Hey, look at that. It did work at 3.
What did I say?
All right. So I know that 3 is a 0, so I would circle it. And then I want to start making my list of terms. X minus 3. That is now a 4th degree polynomial. All right. I got 5 terms, 4th degree polynomial, so why not check and see if there's multiplicity? Okay. So try 3 again. Oops, sorry. 3, 9, 19, what, 60, 57, 87, and I'm going to go ahead and say no. All right. We okay with that?
Yeah.
All right. So I go to -3. If I try -3 now, that gets me -9, 1, -3, 27, -81, and then 9, and -27. Okay. -3 is a 0. What was the term? X plus 3, good. Okay. Try -3 one more time just to see. Yes, sir?
What happens if you do the positive 3 and
It does win here. What happens a lot, this is a good question. If the 3 worked again, that just meant that it had multiplicity. So you would have had 2 zeros or 2 terms of x minus 3. That's all that means. Okay. So if I try -3 again, if I do the -3 one more time, so let's see, 3, then we have a -9, -8, what is this, 24, and that's not going to get me. It's close, but
Do it again.
well, 3 times -3 is -9, add them, it's -8, and that's positive.
Oh, it's a positive.
Yeah, okay. Okay. This might be a good one to try with the 1/3. But if I try 1/3, what's a third of 3? 1. 1 plus 1 is 2, then I get 2/3, and that doesn't look very good. But now what? What's 1/3? I'm sorry, -1/3 times 3. -1. What's -1 plus 1? 0. What's 0 times -1/3? What's a third of 27? Wow. You get -9.
Oh, wait.
Now, all right. And if you think about it, what was your leading term coefficient? 3, right? So the 0 that gives you -1/3, wouldn't that have to be 3x plus 1?
Oh.
As you start to multiply all that out, you got to have that leading term of a 3, don't you?
No.
All right. So now, this was a 4th degree, correct? Okay. Now this means I'm left with what? I'm left with a 3rd degree, so it's 3x cubed plus 27.
Oh.
Isn't that a sum of cubes?
Yeah.
So I'm trying to find a 0 here. Oh, actually, I'm sorry. In this case here,
Why is it cubed?
because remember we started at 5th, 4th, 3rd. Oh, I'm sorry. Sorry, my bad. I got off there. That was my fault. Okay. Here, now you've got, what's your first rule of factoring? GCF. Since I'm finding zeros here, does the 3 have anything left to do with the problem?
No.
Nope. So now you have x squared plus 9 is 0, which means where are your zeros?
Oh, wait, that's not. Oh, 9. Plus or minus 9.
Well, what's the square root of 9?
Oh,
So it's plus minus 3i. So my leftover term here would have been x squared plus 9. Now I have all my zeros. 3, -3, -1/3, and plus or minus 3i. What do you mean, what about the 3? It was up at the top. Because we had a 5th degree polynomial, and I've got 1, 2, 3, 4, 5. And those are my factorials. Are you reading that right now? Let me know when you're done.
Someone spoiled that from me.
Let me know when you're done with that. I've got a great video stuff to show you guys. No, don't say anything. I'll show it to you later.
Sorry.
Let's see here. What page is this? On 6-6, 363. I know it says find all the real zeros. I want you to find, excuse me. Oh, I'm sorry, I don't want to do all. Sorry, hold on. Let's do, I want you guys to do numbers 33 through 37, and then 53, 57. 33, 37. What did I say? 33, 37. These are all odds, okay? And then so there's 6 of them, okay? The PDF file is the 6-6 stuff. I have both PDFs on there, 6-6 and 6-7 right now. I will take off the 6-7 so you don't get confused, but I will type in those problem numbers for you there, okay? All right,